All right, in this section, we are going to determine how to graph a parabola. It is important that you can get enough of an idea about what the shape of a parabola is going to look like to be able to come up with a rough sketch. You're not going to need to have anything super precise at any time, but a lot of times in this class and in calculus, we need to have just an idea of what the shape is. Is it wide? Does it open up? Does it open down? Are the sides steep? Are they less steep? Those sorts of things are important, okay? So sort of the anatomy of a parabola, there's two things that are really important when we are looking at a parabola. The first is the vertex, okay? The vertex is always going to be this bottom point, or if the parabola is upside down, it's going to be this top point. And depending on the form of the equation, you're going to find that differently. You're going to have the axis of symmetry, which is this dotted line here. It's graph dotted because it's not actually a part of the graph. It's just kind of an imaginary line that we use with a dotted line to show. It shows where the line symmetry happens. If you were to fold the parabola in half across the axis of symmetry, then that's where it would be. The axis of symmetry is a line, which is why when you provide the equation of the axis of symmetry, it always has to be an equation. X equals a number. You cannot just give a number. Remember, we've talked about this before. On a graph, a number by itself tells us nothing. It's either an X or a Y or an ordered pair or an equation of, in this case, a vertical line or maybe a horizontal line. So that's really important. We are going to work with two different forms of quadratic functions. We've seen these already. The first one is, this textbook refers to this as standard form, but I've never called it this, and I know that what you learned in Algebra 2 is different. We know this one as vertex form, okay? The vertex form is f of x equals a times x minus h squared plus k. So this looks a lot like your transformations. A is a vertical stretch, h moves it left or right, k moves it up or down. And if the vertex is at 0, 0, and I move right k and or right h and up k, then my vertex moves to hk. So that's why it ends up where it is. Okay, these are the important things. The vertex is always hk. The axis of symmetry is the line x equals h. It must be an equation x equals h. If a is positive, the parabola is going to open up. If a is negative, that causes a reflection, and so the parabola opens downwards. We can also, that's not what I meant to say. When we graph quadratic functions that are in this vertex form, again, that's what we're going to call this one, that are in vertex form, the book gives these 5 steps, which I don't actually love. So here's the main steps that you need to follow, okay? So you can kind of get rid of those. 1, vertex. 2, pick 2 x's, okay? That's all you need to do. Then you're going to graph the vertex and your 2 values and then sketch the reflection. So let's look at how this would work. Now remember, h is always opposite. So when we look at this equation f of x in number 1, the first thing that we need to figure out is the vertex. So the vertex in this case is going to be positive 3, that's h, and then 8 is k. K, you don't switch the sign. So there's our vertex. That's the first step. Now, when I say pick 2 other x's, we want to have a total of 3 points to graph. So 3, 8 was the vertex. That's the first one that we know. And then just go to the right, 4, 5. Pick 2 other x's. And now you can go ahead and plug those into your equation, and you can use your calculator to do that. So we get negative 2 times 4 minus 3, which is 1 squared, plus 8, so this gives us 6. And if we plug in 5, we get negative 2 times 2 squared plus 8. Negative 2 times 2 squared is going to be negative 8, so this gives us 5, 0. Okay, this table is going to represent the right half of the parabola because we counted to the right, 4, 5. If we went backwards, 2, 1, that'd be giving us the left half. So we're going to graph those 3 points and then reflect it over our axis of symmetry. So 3, 8, 3, 8. There's our first point. Because A is negative on this one, our parabola is going to open down, which makes sense with our points. 4, 6, and then 5, 0. That's half of our graph. Now our axis of symmetry is going to be right here. Again, that's an invisible line. It's not actually part of the graph, so you should always sketch it using a dotted line, never a solid line, because that would mean actual values on a function. And now we're just going to reflect each of those points that we already graphed to the other side of the axis of symmetry. Make sure that your parabola is round on the bottom, okay? And also make sure that your graph always goes all the way to the edges of the space you've been given. I don't want to see any parabolas that look like this. That will never be acceptable. If you have the space, you need to fill the space. So go all the way to the edges so we can see what the behavior looks like beyond those points. And that's all that we have to do. Now from here, I could ask you what's the domain, what's the range, all kinds of things. So that is what the graph looks like. I would love for you to pause the video and try the same process on number 2. All right, here's sort of the pre-work here. Your vertex should be -3, +1. And then I counted to the right, -3, and then -2, -1. And I got the values 2 and 5. So let's go ahead and plot those points. This one has a positive value to start, so it's going to open up. -3, 1 is our first point. -2, 2, and -1, 5. Now remember, that's only half of our graph. Here's our axis of symmetry. Okay, so we need to reflect and get the left side of the graph, which is going to be right here. So our graph looks something like that. Okay? Also, if I wanted you to give the equation of the axis of symmetry, remember, it has to be an equation. It's always x equals, and it's always going to be whatever the h part of the vertex is. So the axis of symmetry here would be x equals -3. And I cannot say it enough times, without the x equals, it is wrong. A number has no meaning on a graph without assigning it an x value, a y value, making it part of an equation, an ordered pair, something. Okay. Now, we can also graph in the form of f of x equals ax squared plus bx plus c. This book doesn't even give this one a name, but this is the one that we learned as standard form. And so that's what you'll hear me call it as well, because that's also how I learned it. This one, we're going to use the exact same process to graph. So just like the other one, you can kind of ignore all of that. But finding the vertex is a little bit trickier when it is standard form. The vertex, you're going to start by using this formula. That gives you the x. X is equal to -b over 2a. And then to figure out the y value, you do f of that, which means you plug that in to find the y value. Okay, so that's the extra step that we have to do. After that, the process will be the same. Make a table, pick 2 numbers to the right, and use that to graph your half of your parabola. So let's look at one example here. We want to graph the function f of x equals -x squared plus 4x plus 1. We also want to identify the domain and the range this time. This parabola is going to open downward because it starts with a negative. So the first thing that we have to do is find the vertex. For standard form, that means we need to start with x equals -b over 2a. So for this one, b is 4, so the opposite of b will be -4. A is -1, so this will be 2 times -1, and that comes out to +2. Now, I need to plug that into my function. So if x is 2 to figure out my y value, I now want f of 2. And so that's negative 2 squared plus 4 times 2 plus 1. 2 squared is 4, and then we make it negative, plus 8, plus 1, so this comes out to 5. What all of this information tells us, our x and our f of x, is that the vertex is at 2, 5. Okay, so a little more work. It's not quite as obvious as the first one. But now we do the exact same thing. So I know that the vertex is 2, 5. And if I move to the right 2 places, that's going to be 3 and 4. So let's plug that in. 3 squared is 9, and then we make it opposite. So that's going to be negative 9 plus 4 times 3, which is 12, plus 1. So this comes out to be 4. 4 squared is 16. Make it the opposite. Plus 4 times 4, which is 16, plus 1. This gives us 1. Okay, let's plot the half of this. Remember, our parabola should be opening down. So 2, 5 is right here. Well, let me draw it. Here we go. 2, 5. Then we have 3, 4. And then we have 4, 1. And that's half of it. Now, if you can just sort of imagine that axis of symmetry without drawing it, that's fine. So the other side, when we reflect, is going to look like this. Make sure that your parabola goes all the way to the edges before you stop and put your arrows on. And so there's our graph. So our domain is going to be negative infinity to positive infinity, arrows on both sides. Our range starts at the bottom, negative infinity, and it goes up to 5. So there you go. Okay. All right. That is where we are going to stop here. We spend some time practicing with graphing, and we'll be back a little bit later.